In this tutorial, we will discuss about propositional equivalences, particularly about logical connectors, and the use of truth table to prove logical equivalences. Logical connectors. There are at least 5 common use logical connectors: and, or, implies, biconditional, and negation. Now, I will explain the use and effect of each of the logical connectives. First is and. When we use this connective, both variables has to be true to get a true value. Otherwise, the result would be false, even if only a single variable is false and the rest is true. On the other hand, in using or, the rules are reversed. There only need to be a single variable to be true to get a true value. The only time it is false is when none of the variables is true. Next is the implies. The only time it will yield a false value is when true implies false. All other cases will have a true value. Next is the biconditional logical connective. In this logical connective, both variables need to have the same truth value to be true. Otherwise, the result would be false. The last logical connective is the negation. This is similar to negative in algebra. It reverses the value of whatever variable next to it. For the next part, we will discuss about the truth table. First, we need to learn how to determine the number of rows of the truth table that we will use. Let's use the equation below as an example. First, we count the number of variables used in the equation. This would be A, B, and C. So there would be 3. We will use that value as an exponent to the number 2 as the base. The answer to that would be the number of rows that we will use. Now that we know the number of rows, next would be to know the number of consecutive true values we place for each variable. First, we arrange the letters in a descending alphabetical order. After that, assign the value that we got from the formula to the first letter and divide it by 2. Then repeat the same process, only this time subtract 1 from each exponent for each variables. The truth table for variables A and B would look something like this. Also, take note that the total number of true values for both A, B, and any variables for that case would be the same. There would be 4 true values for A, B, and C. The complete table for the equation that we used before as an example would look something like this. There should be the total number of true values for variables A, B, and C should be the same. There should all be 4 true values for each. Also, take note of the last row of the table. There we can see that all values are false. When that happens, we call it as a contradiction. But when all the values are true, we call it instead as tautology. And when both true and false are present, we call it contingency.